Classmates, in this lesson, we will discuss the overflash ratio in atmospheric tower operation. Let's first understand what temperature 370 degrees Celsius represents. This is the temperature at which a bullet penetrates a wooden block. It can cause calcium peroxide to decompose rapidly. It can cause high-temperature resistant rubber to age quickly. Additionally, it can completely vaporize the gasoline, diesel, and sulfur components in crude oil, meaning evaporation. Next, let's study the partial vaporization of crude oil. Generally, distillation towers have a bottom reboiler, but the atmospheric tower does not use a reboiler at the bottom. Its heat source almost entirely depends on the feed heated by the furnace. As shown in the figure, the inlet furnace temperature is 240 degrees Celsius, while the furnace outlet temperature is 370 degrees Celsius. Although steam is introduced at the bottom of the atmospheric tower, which can also bring some heat, since it only releases sensible heat, and the steam volume is small, this portion of heat is relatively small. Let's further study the concept of overflash ratio in the atmospheric tower. To ensure that the trays below the lowest side stream have some liquid phase reflux, the vaporization rate at the feed section should be slightly higher than the total yield of the products above. This excess portion is called the overflash amount. The percentage of the overflash amount relative to the total feed is the overflash ratio. The atmospheric tower often has multiple side streams. As shown in the right figure, there are several trays between the third side stream and the feed inlet. As shown in the right figure, if there is no liquid phase reflux on the trays below the 14th tray, then the heavier components in the atmospheric residue bottom may move upward into the third side stream product. Therefore, these trays must maintain reflux to avoid dry tray phenomenon. After crude oil enters the distillation tower, it undergoes flash vaporization in the flash zone. The vaporized portion is the output of the rectification section. In the left figure, assuming the vaporization rate is 18%, with overhead product yield 3%, first side stream yield 3%, second side stream yield 3%, third side stream yield 4%, fourth side stream yield 5%, then all vaporized portions are fully extracted, resulting in dry tray conditions below the fourth side stream. If the vaporization rate of the atmospheric tower feed is adjusted to 20%, while the total side stream yield remains 18%, at this point the vaporization rate at the feed section is slightly higher than the total yield of the products above. This excess portion is called the overflash amount. The percentage of the overflash amount relative to the total feed, the overflash ratio, is an additional 2% liquid phase reflux. This 2% liquid phase reflux is the overflash amount. The overflash ratio is 2%. This portion of reflux serves as the liquid phase reflux for the trays below the lowest side stream, ensuring the quality of the lowest side stream product, meaning no heavy components are carried over. Taking the atmospheric tower as an example, the overflash ratio is generally controlled at 2% to 3%. Practice has shown that increasing the overflash ratio by 1% increases the heating furnace load by 2%. This reminds us to develop energy-saving habits in our work, improve energy efficiency, cultivate a conservation awareness in daily life, value labor achievements, and oppose wastefulness. Okay, classmates, that's all for this lesson. See you in the next lesson.